Hello, so today we're looking at the intersection of lines and planes. Okay, so we're asked to determine the points of intersection of the line. So we're given the line R equals 2, 1, 3 plus S times direction vector -4, 1, 8. And our plane 2x minus 4y plus 8z plus 1 equals 0. Okay, so how do we do this? So first thing we can do is look at our line. Let's use a different color. We're going to look at our line and we're going to write it in parametric form. So x equals 2 minus 4f, y equals 1 plus s, and z equals 3 plus 8s. Okay, so now that we have that, we can take each parametric form of the coordinates x, y, and z and plug them into our plane. So why don't we do that? All right, so we have 2 times our x, which is 2 minus 4s, minus 4y, which is 1 plus s, plus 8z, which is 3 plus 8f, plus 1 equals 0. Okay, so now we're going to solve for s and see what we find. All right, so let's expand this out. So 4 minus 8s minus 4 plus 4f plus 24 plus 64s plus 1, and that all equals 0. Okay, so now let's group all the like terms. So we have 4 minus 4, which is 0, plus 24 plus 1, so that's 25. Now, how many s's do we have? We have negative 8s plus 4s, that's negative 4s. Negative 4s plus 64s is actually 60s. All right, so now we're going to solve for s. So s equals a negative 25 over 60. I think we have at least a common factor of 5. It looks like our s is negative 5 over 12. Okay. All right, so now what's our question? Our question is determine the points of intersection of the line. So it might just be one of intersection of the line and the plane. Well, we found one value for s, and we found that s to be negative 5 over 12. And we got this s value from plugging in the parametric form of the equation of the line into our plane. That means we found the s value for when our line intersects our plane. So we're going to find that point, and how we're going to do that is we're going to take that value of s equals a negative 5 over 12. We're going to plug it into our point. So either they're a vector or parametric form. So let's do that. Let's plug it into the parametric form. So therefore, x equals 2 minus 4 times negative 5 over 12. Y equals 1 plus negative 5 over 12. And z equals 3 plus 8 times negative 5 over 12. All right, let's simplify. X is negative 2 plus 3. So we get plus 5 over 3. Y equals, let's put everything over a common denominator. Okay. Z equals common factor 4, I think. 3 minus 10 over 3. Okay, let's keep simplifying. We get some values for x, y, and z. Putting everything over a common denominator. All right, right. So x is 11 over 3, y is 7 over 12, and z is negative 1 over 3. So therefore, line intersects plane in point 11 over 3, 7 over 12, and negative 1 over 3. All right, that wasn't too bad. Number 2, determine the points of intersection of these two lines. All right. Okay. So now we have two lines. We want to see where they intersect. So we got line 1 and line 2. So again, for line 1 and line 2, we're going to write out that parametric form. X. So line 1, we have x equals 1 plus t, y equals negative 3 plus 4t, z equals 4 plus t. For line 2, we have x equals 4 minus 3t, y equals negative 2 plus 2t, and z equals 6 plus 3t. Okay. Let's see. All right, so when these two coordinates, when these 2 points are equal, then our lines intersect. Now, what I think we should do is not use the same parameter. That's going to get confusing. So let's use t and s. There, that's better. So t is a real number because they're not necessarily the same real number. All right. Okay, so now let's let them equal. So line 1 equals line 2. That's when they're going to intersect. And what do we have? We have 1 plus t equals 4 minus 3s. Negative 3 plus 4t equals negative 2 plus 2s. And 4 plus t equals 6 plus 3s. So now we're going to try and solve for t and s. Let's see if that's possible. All right, let's first clean up these equations. All right, let's see. Let's bring everything onto one side of the equal sign. So we have 0 equals, let's see, 3 minus 3s minus t. Looks right. 0 equals 1 plus 2s minus 4t, and 0 equals 2 plus 3s plus t. So now we have 3 equations and 3 unknowns. We want to see if we can solve for s and t, our 2 unknowns. Let's give some numbers to our equation. 1, 2, and 3. All right. Let's see if we can use equation 1 and 3 and some elimination here. That might be a problem. All right, let's try. Our lines may not intersect at all. Okay, let's try 2 and 3. Okay, let's see what we can do here. Well, let's do 2 times equation 3. So 2 times equation 3. What does that give us? 0 equals 4 plus 6s. Actually, let's do 4 times equation 3. There. That's probably better. Then we get 4 plus 12 plus 4t. So now we have equation 2 and 4 times equation 3. Let's add them together. Let's go over here. So we have 0 equals 1 plus 2s minus 4t. 0 equals 4 plus 12s plus 4t. We're going to add them together. And what do we get? 0 equals 5 plus 14s plus 0t. Now we can solve for s. Negative 5 over 14 equals s. Oh, okay. Let's see if this works. Okay. All right, so we have an s value. So let's plug it in here and see if we can find t. See if that works. All right. So equation 1, we have 3 minus 3s. 0 equals 3 minus 3s minus t. So we have 3 minus 3 times negative 5 over 14 minus t. And that equals 0. 3 plus 15 over 14 minus t. Let's bring the t over to the other side. So we have t equals 3 plus 15 over 14. Let's put everything over a common denominator to make it a little neater. So we got 42 plus 15 over 14. And we have t equals 57 over 14. All right. All right, now let's see if that makes sense. May or may not. I'm a little skeptical. And the reason I'm skeptical is equation 3 and 1. We notice, so let's do a quick check. So if we did 1 plus equation 3, so I'm just writing them out again. We're going to add them. So we get 0 equals 5 plus 0 s plus 0t. Well, we get 0 equals 5. That doesn't make sense. If it doesn't make sense, that probably means our two lines do not intersect in a point. But we got values for s and t using using equation 2 and 3. So I'm going to say there is no point of intersection of these two lines because we have this inconsistency if we look at equation 1 and equation 3. Now what we can do is we can now put s in here and t in here and see if we get the same point. If we don't, then we probably don't have a point of intersection. So let's try that. So what do we have? We have s equals negative 5 over 14. So let's do this in a different color, keep things separate. So plug s equals negative 5 over 14 into line 1. Or is it into line 2? Yes, and see what we get. So we get x equals 4 minus 3, negative 5 over 14. Y equals negative 2 plus 2 over negative 5 over 14. And z equals 6 plus 3 times negative 5 over 14. All right, so let's calculate these values. All right. right, so let's put everything over a common denominator, see what happens. Okay, and finally 6 times 14, 84 minus 15 over 14. Oh, sorry, 6 plus 71 over 14. Good. All right, so an equation on line 2, rather, our point is we have point 71 over 14, 18 over 14, and 69 over 14. Okay. Now, what is our t value? Our t value is 57 over 14. I don't believe that's going to work. So, line 1, t equals 57 over 14. Let's plug it in and see what happens. X equals 1 plus 57 over 14. Y equals negative 3 plus 4 times 57 over 14. And Z equals 4 plus 57 over 14. All right, so we have 14 plus 57 over 14 equals negative 3 plus, let's see, 2 times 57 over 7, and 4 times 56 plus 57 over 14. Well, let's look at this value. All right. Okay. So our Z component on line 1 is 113 over 14. However, the Z component on line 2 is 69 over 14. So already we know, therefore, there's no point of intersection. There is no point of intersection between lines L1 and L2. All right, so we've actually shown this 2 different ways. So let's review. It's a bit of a messy problem. No point of intersection. Let's go back. So we're asked to determine the points of intersection of the lines L1 and L2. We should put if exists. All right, so the first thing we did was we rewrote line 1 and line 2 in parametric form. And then we equated the coordinates, the x coordinates and y coordinates and z coordinates together. That then gave us 3 equations and 2 unknowns. Those are 2 parameters, s and t. From here, we want to try and solve for s and t. Well, if we do it one way, or if I had done it one way, where I took equation 1 and equation 3 and added them together, we would have seen that 0 equaling 5 makes no sense. So there's no point of intersection. So even just from here, we could have written no point of intersection. All right. However, that's not the route I went. Instead, I looked at equation 2 and 3. And using those two equations, I found that I could find values for S and T. They were a little strange, but I could find them. So then I took these values for S and T and plugged them into their respective lines. So when S is equals -5/4, I plugged that into line 2, and I got the point 71/14, 18/14, 69/14. When t equals 57/14, I took that point and I plugged it into its line 1. And I started doing the calculations to find the point. And we found that the z coordinate was 113/14, and that does not equal, this does not equal, what was the z coordinate for line 2? 69/14 does not equal 69/14. So based on this, we're able to conclude there is no point of intersection between lines L1 and L2. So there's two ways we could have found this out. I think the other way is a lot easier, finding that, taking equation 1 and 3, adding them together and seeing that 0 equaling 5 makes no sense. That brings us to the end of our session today. If you have any questions, send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we look forward to seeing you soon.